I need to cover up the holes on this. Who is this guy? Google Hanson Robotics, realistic humanoid robot or something like that. They just had a news story on CB, some news station, about this guy's robot. I don't like the guy because he's deceptive. He tries to make you think his robot's really smart and it's not. This is the output shaft of the motor. This is a motor covered in tape. This thing's going to turn and it's going to wind up thread. As it winds up the thread is going to be pulling. And that's going to simulate muscles pulling. And muscles pulling makes the arm or the body or whatever part move. That's how muscles work. They pull. So this little motor is essentially a muscle actuator. Now, if I'm to wind string on here, it can't be just going all out of control. So I need to add walls. Like extrusions coming out this way, like this wide, so that the string as it winds doesn't come off. It's basically like a fishing reel. So once I get the and taper of this correct, I'm going to build the little walls and glue them on. And I'm going to use my my UV glue. Woohoo! Yeah! It's got to look like that. So those three lines are going to be spindles so that it ultimately will look like this. And these two are strings. So as it winds, it pulls the strings like a fishing reel. And here's another view. So I got to add the spindles now. I don't know if that's the word, spindles, but whatever. Something like that word. Now, I'm not clear on what to use. I'm thinking like plastic, but actually even this paper, what I was going to use to cut out on, I could actually use. Okay. I'll make a series of measurements. Needs to be 1.5 centimeters. Okay. The reason I'm using a cardstock, like a business card type paper, is because I can reinforce it with glue afterward. Um, Bam! Perfect fit. So that's one of three. I'm still gonna need one more here, one more here. All right, now to glue it, I want to use my UV curing glue because it's so fast. It's not the strongest, but I don't think strength is a big concern. In this application, let's see. Uh, I should have not glued the cardboard down because I could have used it to measure and cut out the next piece of cardboard. Oh well, it's already glued now and it's on there pretty good. But I think epoxy is still a bit stronger. I don't want to use up all my UV glue. I find that to be special glue because it's very expensive. I want to use it sparingly. Okay, I need gloves. Okay, I barely need any epoxy. Even that was too much. Way too much. Oh, check it out, guys. The thread will be able to pass right through inside there. As the motor spins, it will wind the thread. but I want it dual acting, so I need one more right here so that I'll have 3 of them, and I'll be able to have one thread winding while the other one is releasing. And those will represent the opposite muscle groups. So when this turns clockwise, one muscle will be pulling, and then the other one, which will be connected in a counterclockwise fashion, will be pushing. And so one muscle will release while the other pulls, and opposing muscles is how the body's muscle system works. You have your biceps, which are opposed by your triceps, and so on. You have your hamstrings, which are opposed by your quadriceps. So every motor will be able to handle 2 muscle groups, one opposing and one pulling. So it's just really cool design. In theory. This is just so cool, man. This is coming out exactly like my drawings. It's rare that something turns out the way you drew it. You know, like, usually when you draw something, you hope for the best, but you doubt it's going to work out. I just got to add one more thing and then probably shave off the end. I'll just add the one more right here. And I have to coat this one in epoxy. So after I put the cardstock spindle on, I coat it in epoxy to give it a little more rigidity and strength. And then what I'm going to do is just glue down the upholstery thread, wrap it a couple times, maybe glue it a little more, wrap it a couple times. Once I get it started, it should be fine. I don't think it'll I don't think it will pull off once I glue it and wrap it several times. And then as this turns, it's going to pull on the thread. So I'll have alright, let's just say this spool of thread is our muscle or our load that we're trying to pull, and as the servo turns, it's going to pull the muscle. And as that happens, the arm's going to bend or whatever. Wherever this string is connected to the arm or to the finger or what have you, that joint will move. So this motor then acts sort of like a muscle. And it moves whatever you attach it to. It turns rotational force into linear force, a pulling effect. And I think it's going to work excellent. There's going to be hollow tubing going over this string though to prevent it from fraying and also protect it and guide it. Sort of like the rubber tubing that goes over your bike brakes. my whole design for the muscle system is based upon my understanding of how bike brakes work, handle brakes, and that's pretty much the inspiration for my musculoskeletal system design. I think this is going to work excellent. And this is so tiny, it'll be able to fit like 100 of these in the arm. And this is the bigger size motor. I bought the Tower Mini servo motors off eBay, and those motors are about 1/4 of this size. So I'll be able to make a micro version of this and have even tinier motors, which I can fit like inside the head to control the facial expressions. I can fit them inside the forearms, which is, you know, a smaller muscle group. Your forearms aren't that big, especially a female's forearms. And I'll be able to fit those tiny, tiny motors even in stuff like the forearms. Maybe even I could fit a motor or two in the palms of the hand. So the idea is to fit as many motors as I can in as many areas as I can. And because I went down to this tinier motor, I'm able to fit it in a tiny area. If I were to have kept the original motor, this came out of one of these, you can see that I would not be able to fit these much of anywhere. Look at the form factor. Look at the difference in size. You got tiny, tiny, tiny. You got humongous. Like you just can't fit one of these in the palm. How would that fit in my palm? It'd be sticking out. But something 1/4 this size will fit. So bottom line is, by me removing the insides of this and removing its gear train and just going with this, although I lose the down gearing, I gain an extremely small form factor. And I don't think I wanted the down gearing anyways, because I'm going to want these muscles to be able to pull very quickly, because like, look how fast fingers move. I mean, like the human body moves fast, so I don't want some slow turning servo motor. I want it to be raw speed coming straight out of the motor like this. So I think that I don't need the down gearing, so I save on weight and size right there. Is there larger shaft on top of the motor shaft? How did you attach it? This gray thing is epoxy putty, and I attached that to the tiny copper geared motor shaft. It's a splined motor shaft. I just smashed it on like this, boom, and I let it cure. And then, in order to make this look so clean and neat and round and perfect, like a piece of chalk, I carved it with my exacto knife. I just carved this until it looked perfect. Little by little, you could see the powder coming off. I also was able to use a Dremel blade, this, to cut it as well as grind it. You can just run it along it. So I was able to perfectly hone it to exactly the shape I wanted using those two tactics. And the epoxy that I use, the epoxy putty, is really powerful stuff. Like, it's called plastic epoxy putty. Actually, this is not the one I used. Take that back. I used this one. It's Pro Poxy 20 Steel Reinforced Epoxy Putty. Steel hard repairs in 20 minutes. Once you mix this together like Play-Doh in your fingers, you can just jam it onto the motor in order to make a larger motor shaft extension. And then for these little wings I put on it, or spindles, whatever you want to call it, I just cut them out of cardboard. And then after I cut them all out, I ground a little hole through them with my, like this, with my exacto knife. And I just slid it down, I glued it on. And then I'm going to reinforce the cardboard with a little bit of epoxy, this 5-minute epoxy. That will make the cardboard more rigid. It doesn't need to really be that rigid, since all it is a guide for the string to prevent the string from, like, you know, like winding off the side. Like if it didn't have the guide, it could accidentally do that and then unravel. So the guide just keeps it in here and manages the string so that it stays in its place on the shaft. That's all it's for. So it doesn't need to be load bearing or tough or anything. But what does need to be load bearing and tough is this shaft, and it is. It's really hard. It's like a rock. So that's a summary of where I've come from so far. What I'm going to do after I've connected the rope, connected the final little spindle on the end, and then shave this down to size, is I'm going to wrap this on in double stick industrial strength tape, and then wrap it in fabric, sew it all really tight on there, and then sew the fabric down onto the cloth coating of the bones of the arm, so that this will all be sewn in and mounted really tight on the arm. And then I'm going to run this to the different muscles